Hello, welcome back to Hocus Focus. Today we're going to be looking briefly at arithmetic progression. So without further ado, let's get right into it. This is actually kind of an easy topic. So let's take a look at and that continues on in that vein. Continues on. Right, you get the point. So each one of these is an arithmetic progression, but what does that mean? What it means is that from a given starting point, not all the time, we'll get into that in a moment, but from a given starting point, you always increment in the same amount each time. We actually have a convenient equation going for a standard arithmetic progression. That being okay, so this is our first term. And this is how we calculate subsequent terms. So the 1 and the n here signify where we are in the series. 1 being the first, and n being the wherever we are after that, right? So if we're saying, for example, that n is equal to 2, we are in the second one of the series. And we're going to say that 1 is equal to 5. And then this d is the difference between the two numbers, right? The intended difference per step, I should say. We're going to say that's 5 as well. So according to this, we would have 5 plus 2 minus 1 is equal to 1, so 5, so our A2 would be equal to 10. This also works for the first step. Obviously. It doesn't even matter what t is for this one, because this evaluates to 0. So you would just get 5. So it does work for the initial step. It works for steps after that. So what we have here is, for as long as we have n, we have that many steps. So if we say that we have an arithmetic progression on a scale from negative n and we'll do this, yeah. Negative n to n, right? So we're going from negative n to n, where n is expected to max out at 100. You would have a set of 100 steps going in either direction, right? And in this case, we'd probably want the initial value to start at 0 instead of 1. But typically when you're first learning it, you don't really need to know that. You just need to know, like, 1's going to be the first step, and then n is going to be whatever subsequent step that you get to, right? Okay, so that's all pretty easy, right? I think where a lot of confusion for something like this would come into play is differentiating between an arithmetic progression and whatever other kind of series you have. Because the arithmetic progression is exclusively this, right? Like, this is what we're looking at. So, when I first learned it, my source of trouble was seeing patterns that made sense and that I could figure out and attributing that to arithmetic progression rather than applying the definition exclusively, right? So, if you see something like this makes sense. It follows a logical path, and you can predict each subsequent step based off of the information that you're given. Now, this is not an arithmetic progression because each step should be D. So here we have a difference of 2. Here we have a difference of 4. Here we have a difference of 8. Right. So this is not an arithmetic progression. Let's say we have something like 50, 38, 26, 14, 2, -10, going on. Okay, so does this make sense? Yes, it does. What's this step? That step's -12. What's this step? -12, -12, -12, -12. Is this an arithmetic progression? Yes. Okay. So that makes sense. So this can go on for whatever value you want, right? However many n you want. And you can cap it where you want. It doesn't have to be infinite. But it can be. And it can also be doubly infinite, right? So those are just some things to kind of look out for. Okay. This was pretty brief. It was pretty quick. But if you have any questions, if you think that I went wrong somewhere, if there's anything that you would just like to bring up or ask for next time, go ahead and let me know. Write a comment out. And I have 0 comments, so rest assured you will be getting all of the attention. I will try to read each comment, even if there's 0. But, with all that out of the way, I hope you all have a wonderful day. This has been Hocus Focus.